Hello everyone, myself Faaiz and I'm from AIIMS Nagpur. Today we are dealing with chapter wave optics. Okay, so without wasting any time, let's start. Okay, the first concept is interference. Yes, the first concept is interference. So the mode of session will be we will discuss important concepts, theories, formulas, equations, and we will solve maximum number of previous year questions. Okay, so be with me. Yeah. So let's start interference. Okay, let's see. I have source of amplitude A1 and I1. Okay, and amplitude A2, I2. We know that intensity is directly proportional to square of amplitude, right? Okay, so Y1 we can write as A1 sine kx plus or minus omega t, right? And Y2 is A2 sine kx plus or minus omega t plus, having a phase difference, suppose phi. Okay, so we have y1 source having amplitude a1, intensity i1, and y2 source having amplitude a2, intensity i2, and phase difference between y2 and y1 is phi. Okay, so we have to find what is y net, right? Y net will be y1 plus y2, right? It's vector addition, right? Easy. So vector addition. Suppose y1, this is a1 and this is a2, and the phase difference between a1 and a2, y1 and y2 is phi. So the resultant a net will be this. Easy. So a net will be a net will be a net will be how much? Root of a1 square plus a2 square plus 2 a1 a2 cos 2 a1 a2 cos phi. Okay, this is a net. We know that intensity is directly proportional to square of the amplitude. So intensity net intensity will be how much? I1 plus I2 plus 2 root I1 root I2 cos phi. Okay, easy. Yeah. So we got very important to formula. Net amplitude and net intensity. Okay. Suppose if constructive interference happens if constructive interference happens, we know that cos phi will be equal to 1, right? So in that condition we can write net amplitude as a1 plus a2. Easy. And net intensity, that will be the maximum intensity, right? Maximum or net intensity will be how much? Root I1 plus root I2 whole square. Okay, simple. Yes. And if destructive interference happens, we know that cos phi will be -1. So in that condition, the net amplitude and net intensity will be minimum. That minimum net amplitude will be a1 minus a2. Let's take mod. Then net intensity will be how much? Root I1 minus root I2 whole square. Okay. Yes. Easy, right? Yes. Okay, simple. Yeah. The next concept we have to study is what? Phase difference. Phase difference due to path difference. phase difference due to path difference. Phase difference due to path difference. Yeah, the equation relating phase difference and path difference is delta phi equal to k delta x. Okay, we know that 2 pi by lambda. Okay, so we can write as delta phi equal to 2 pi by lambda delta x. Okay, yes, in constructive interference, and in destructive interference. In constructive interference, yeah, delta x will be n lambda, means lambda 1 lambda, lambda 2 lambda 3 lambda, like integer multiples, and in destructive interference it will be odd multiples. Yeah, path difference will be odd multiples. We can write as 2n minus 1 into lambda by 2. Okay, easy. Yeah, it's first question. Two coherent sources produce waves of different intensities which interfere. Okay, different intensities. Suppose intensities I1, I2. Okay. After interference, the ratio of maximum intensity to the minimum intensity is 16. The intensity of the waves are in the ratio. We have to find out I1 by I2. It is given that the ratio of the maximum intensity to the minimum intensity is 16. Okay. What's the formula of maximum intensity? What's the formula of maximum intensity? Root I1 plus I2. Root I1 plus root I2 whole square. So we can write as root I1 plus root I2 whole square divided by what is minimum intensity? Yes, root I1 minus root I2 whole square. And its ratio is given, that is 16. We can write 16 by 1. Okay. So if we take square root both side, we will get root I1 plus root I2 divided by root I1 minus root I2 as 4 by 1. Cross multiplying both the sides, we will get root I1 plus root I2 equal to 4 root I1 minus 4 root I2. So 5 root I2 equal to 3 root I1. I'm squaring both the side. 25 I2 equal to 9 I1. Or we have to find out I1 by I2. So I1 by I2 will be 25 by 9. 25 by 9. So option B will be the correct option. Okay, easy. Yes, the maximum intensity will be root I1 plus root I2 whole square. Maximum intensity will be root I1 plus root I2 whole square. And the minimum intensity will be root I1 minus root I2 whole square. Okay. Yes. Next, let's see. If A1 and A2 are same and it is equal to A0, equation will change, right? So let's see how it will change. So we know that, so A net will be, we know A net is root of A1 square plus A2 square plus 2 A1 A2 cos phi. So here will be A naught square plus A naught square plus 2 A naught cos phi, right? So A net equal to root of 2 A naught square plus 2 A naught square cos phi. Okay, so A net will be root of 2a square, I can take common, 1 plus cos phi. Okay, 1 plus cos theta I can write as 2 cos square theta by 2, right? So using the trigonometric relation net equal to 2 a0 square into 2 cos square 5 by 2. So a net equal to root of 4 a0 square cos square 5 by 2, or a net equal to 2 a0 cos 5 by 2. This will be the equation for net amplitude. If A1, A2 are same and equal to A0, 2 A0 cos 5 by 2. And intensity, net intensity will be, just square it, right? For A0 square is I0 cos square 5 by 2. Oh, okay. Easy. Yeah. Easy. Suppose in constructive interference, what will happen in constructive interference? Yeah, a net, that is a maximum, will be A1 plus A2 to A0, and net intensity or the maximum intensity will be root I1 plus root I2 whole square, right? So here it will be how much? Yes, root I0 plus root I0 whole square, 2 root I0 whole square, that is 4 I0. Okay, and destructive interference, A1 minus A2 0, and net intensity will be also 0. Root I1 minus root I2 is 0. Okay. Everybody understood? Yeah. So this is our moving to next question. Two coherent sources sound S1, two coherent source of sound S1, S2 produce sound waves of same wavelength lambda equal to 1 meter in phase. S1 and S2 are placed 1.5 meter apart. A listener located at L directly in front of S2 finds that the intensity is at minimum when he is 2 meter away from S2. The listener moves away from S1, keeping his distance from S2 fixed. The adjacent maximum of intensity is observed when the listener is at a distance d from S1, then d is. We have to find out d. To find out this distance d. Okay, let's solve it in a see. The picturize the condition is like, yeah, S2, S1, source of sound. Yes. Distance between S1 and S2 is 1.5 meter. It is given. Right. First case, listener is here. From S2, the distance is 2 meter, right? And from S1, what is the distance? That we don't know. Okay. And it's saying that first case, minima, right? Minima happening, right? Isn't okay, right? Ideally, students is minimum. Okay, intensity is at minimum when he's 2 centimeter away from S2. So before that, so let me discuss about maximas and minimas. Okay, maximas and minimas. Maximas and minimas. First, minimas. Okay. Minima will be, we know that, yes, delta x equal to odd multiple of lambda by 2, right? I have already told that. So this will be like lambda by 2, 3 lambda by 2, 5 lambda by 2, 7 lambda by 2, etc., etc. Or like 0.5 lambda, 1.5 lambda, 2.5 lambda, 3.5 lambda, etc. Minima's path difference will be all the multiples. Case,
Progress.
yeah, listener is having next maxima, right? Yes. This distance we can find out how. Pythagoras theorem, 2 square plus 1.5 whole square, 4 plus 1.5 whole square, 1.5, 225, that is 2.25. So will be root of 6.25, that is 2.5 meter. Yeah. Right. Yeah. So in first case, what will be the path difference? Path difference will be S1L minus S2L. Right, simple. S1L minus S2L. S1L is how much? 2.5. S2L is 2. This will be 0.5. So delta X equal to 0.5. What's happening? Minima. Yes. So path difference is 0.5. Then yeah, then we can write as 0.5 lambda. Yes, right. Lambda by 2, 3 lambda by 2. Yes. Okay. First case. In second case, path difference is how much? This is first case, second case. Path difference is d minus 2. Right? D minus 2. And we know that what's happening at second case, next maxima. Next maximum means, yeah, at 0.5 lambda minima, the next maximum is lambda. Right? So this is equal to 1 lambda. Okay. And if we subtract delta x2 minus delta x1, we will get how much? Lambda minus 0.5 lambda. That is lambda by 2. Right? Yes. So our answer will be option number D. Right? Yes. Yeah. D will be 3 meter. Easy. Yes. Moving to next question. Yeah. A ray of light of intensity I is incident on a parallel glass slab at a point here as shown in diagram. Undergoes partial reflection and refraction. Each reflection, 25% of incident energy is reflected. The rays A, B, and A dash, B dash undergo interference. Okay. At last, this rays A dash, B dash, and AB is undergo interference. The ratio of I max to I min. So before that, we have to find out what is intensity of AB ray and A dash, B dash ray. For that, it is saying that it undergoes partial reflection. At each reflection, 25% of incident energy is reflected. So let's see. Right. So 25% of incident energy is reflected. So here it will be I by 4. The refracted will be how much? 3I by 4. Right. 3I by 4. Okay. And 1 by 4th of 3I by 4 will reflect. 1 by 4th of 3I by 4. 3I by 4 into 1 by 4. That is how much? 3I by 16. 3I by 16. And 3I by 16. So the reflected portion will be 1 by 4 again. That is 3I by 16 into 1 by 4. And this will be how much? 3I by 16 into 3 by 4. This will be 9I upon 64. Yes. Okay. Now it's simple, right? Yeah. Now it becomes like, yes, AB array having intensity I by 4 and
Recording in progress.
Value of n is 9. Okay. Moving to very famous Young's double slit experiment. Young's double slit experiment. We will see important equations. Okay. This distance is small. Yeah. This is the screen we have. Right. And the separation is capital D. Right. Okay. I'm observing at point P. Right. Yes. And this angle is theta. Okay. And the distance point P is Y. Yeah. Okay. At here, what will happen? Central maximum. Okay. So important equations are here path difference will be, suppose this is S1, this is S2, S2P minus S1P. Using trigonometry, we'll get d sine theta. We have already derived these formulas. X is equal to d sine theta. Right. Okay. Yeah. If y is small, theta is also small. If theta is small, we can say that theta approximately equal to sine theta, which is approximately equal to tan theta. What is tan theta here? Y upon capital T. So we can also write as delta x is equal to dy by d. But the difference we got second equation. Alright. The next important thing is we know that for maximas, what is the condition? Maxima, what is the condition? Maxima, the condition is delta x should be equal to n lambda. Right. So we can say that we know the equation. What is the equation for delta x? Equation for delta x is, yes, here we saw no, dy by d. Dy by d, and this should be equal to n lambda. From this will get that y distance will be how much? N lambda d by d. So the integer multiples of lambda d by d. And for minima, the condition is delta x is 2n minus 1 lambda by 2. So yeah, this we can say the maximum y max. And here we will get y minimum as how much? 2n minus 1 into, we can write like this, 1 by 2.5 lambda d by d. And second minima will be 1.5 lambda by d. Or second maxima will be 1 lambda by d. Right. So the fringe width is difference, separation between two maximum or two minimum. That is lambda d by. Oh, yes. Easy, yes. Yeah. So next is our question. In a Young's double slit experiment, a light of 500 nanometer is used to produce an interference pattern. When the distance between the slits is 0.05 millimeter, angular width in degree of the fringes formed on the distance screen is closed. You have to find out angular width of the fringes. Angular width of the fringes. See, remember this is angle theta, right? Suppose here is the central maxima and here is the first maxima. Suppose this is the case. So this distance y we can say as beta, right? Fringe width is between, separation between adjacent maxima. This is the central maxima This is first maximum. This is beta. And this distance is capital D. So we can say that theta equal to beta by D, right? And beta is, we know, lambda. So the angular width of fringes will be lambda by. Okay, so we got the equation. Just put those values, right? So theta equal to lambda by D. Lambda is how much? 500 nanometer. 500 into 10 raised to minus 9. And separation between the slits 0.05. 0.05 millimeter. That is 5 into 10 raised to minus 2 into 10 raised to minus 3. This will be how much? 5 into 10 raised to minus 7 divided by 5 into 10 raised to minus 5. 5 gone. 10 raised to minus 2. That is 0.01. 0.01 radian. 0.01 radian, right? But we have two options are in degrees. And we know 1 radian equal to approximately 57 degree, right? So 0.01 radian will be approximately equal to 0.57 degree, right? 0.57 degree. So which option is correct option? Option B is the correct option. Easy? Yes. Into next question. Interference fringes are observed on a screen by illuminating two thin slits 1 millimeter apart, yet small d given, light source lambda given, the distance between is given, capital D given. If a bright fringe is observed on a screen, bright fringe means maxima at a distance of 1.27 millimeter from the central bright fringe. Okay. Then the path difference between the waves which are reaching the point from the slits is close to. Yeah. So what we know from the question. Yeah. That's the first thing. Saying that from central maxima, yeah, somewhere else maxima is happening. The distance between the central maxima and the point where maxima happens is 1.27 millimeter. 1.27 millimeter. Am I right? Yes. 1.27 millimeter. You have to find out path difference at, suppose this is point P. Yeah, path difference at point P. This is 2.8 nanometer. Capital D is given 100 centimeter. How do we proceed? Let's see. So we know the equation delta x difference equal to, and also we have delta x is equal to, yeah, d into y by d. If theta is small, and for maxima, at maxima our constructive interference happens, we know that y equal to n into lambda d by d, right? Here y is given how much? 1.27 millimeter. We don't know the n. Yeah, the nth maximum. We don't know the n. So to find out first n into lambda is given 6328 nanometer into d divided by small d is 1 millimeter. So how much will nanometer, millimeter? Okay, so this will be millimeter. This will be 10 raised to minus 6. Nanometer, centimeter, 10 raised to nanometer, 100, 10 raised to minus 7. Raised to minus 7 and centimeter, 10 raised to minus 5. Raised to minus 5, yes. Raised to minus 5. 10 raised to minus 5, right. So n will be how much? N will be 632.8 by 1.27. Approx, and we are getting 2. N is 2. So we got N is 2. Okay. The question is what? And the path difference between the waves reaching this point from the slit is called close to. Okay. N is 2 into lambda d by d. Right. Yes. So option I think A seems to be the correct option. This is our next question. Consider a Young's double slit X figure. What should be the slit separation small d in terms of wavelength lambda, such that the first minima occurs directly in front of the slit. Okay, first minima is occurring. Here see the slit separation and the separation between screen and source is d and 2d. So we cannot say theta is small here. So we cannot use delta x is equal to d sin theta and yes, delta x is equal to y d into y by d. Right. So here what we are going to do is s1 s2. This distance is small d. Here is the point p here. And this distance is we don't know. And this distance we know 2d. Right. So this distance is also 2d. This distance will be root of d square plus 2d square. That is root of 5d square. That means root 5 into d. Right. So, and they are saying first minima. So first minima will be where 2n minus 1 by 2 into lambda d by d. Right. Yeah. Or first minima will be where 0.5 lambda. Right. Path difference will be 0.5 lambda for first minima. So here path difference is how much? Root 5d minus 2d, which is equal to 0.5 lambda. Yes, we have to find out what should be the slit separation. D. Okay, D. So small d. So small d will be 5 minus 2 into lambda by 2. So d will be lambda by 2 into root 5 minus 2. Lambda by 2 into root 5 minus 2. Option A is the correct option. It is our Malus law. Malus law saying see, okay, if an unpolarized light having intensity I naught goes through a will be plane polarized and its intensity will be I naught by 2. It will be plane polarized. Intensity will be I naught by 2. And this plane polarized light, suppose a plane polarized light is coming of intensity I, and the angle between the polarizer and the plane of polarized light is theta. Yes. The outcoming light will have intensity of I cos square theta. I cos square theta. Easy. I cos square theta. This is the condition. Here a system of 3 polarizers P1, P2, P3 is set up. Path axis of P3 is crossed with respect to that of P1. Okay, same axis. The path axis of P2 is inclined at 60 degree to the path axis of P3. When a beam of unpolarized light, UPL, intensity I naught is incident on P1, the intensity of light transmitted by the three polarizers is I. The ratio of I naught by I is equal to nearly. Let's solve this. In first case, yeah, right. This I naught by 2 is passing through P2. P2. Path axis of P2 is 30 degree, right? Because P3 is like this, right? So this angle should be how much? 60. This angle will be 30 degree. Okay. So light coming through P cos square 30. This will be how much? I naught by 2 into cos 30 root 3 by 2, 3 by 4, 3 I naught by 8. Right. This 3 I naught by 8 3 I naught by 8 angle is 60 degree. P. So 3 I naught by 8 into cos square 60. That is 3 I naught by 8 into 1 by 4. That is 3 I naught by 32. Right. 32 by 3. 32 by 3, 10 point something. 10 point something, which option? Yeah, option C. 10 point something. So 10.6 up. Okay. Yes. Moving to next question. Calculate the limit of resolution of a telescope objective having a diameter 200 centimeter if it has to detect light of wavelength 500 nanometer coming from a star. Yes. Question is given equal by the equation what? Theta equal to 1.22 lambda by, we know lambda, right? Yeah, lambda is how much? So yeah, values will get the answer. Formula we have 1.22 lambda by d. Yes. Yeah. Yeah. This is next question. Unpolarized light of intensity I is incident on a system of two polarizers, A followed by I by D. If the polarizer C is placed between A and B, intensity of emergent light is reduced to I by 3. Angle between the polarizers A and C is theta. Then again a similar sort of question, right? So light coming through polarizer A will be I naught by 2. But the intensity of emergent light is I by 2. Yeah, obviously, the third polarizer C is placed between A and B. The intensity of emergent light is reduced to I by 3. Okay, the angle between the polarizers A and C is theta. Then, okay, this is interesting. Yeah, in first case, polarizer A, polarizer B, right? Yeah, unpolarized light is coming. So this intensity will be I naught by 2. And passing through here also intensity is I naught by 2. So here theta is 0, same axis. That's why same I naught by 2. And in second case, a third polarizer is coming in between A and C. We don't know the path axis of third polarizer, but A and B are having same path axis, right? So A, B, C path axis like something theta. Theta is given, right? This will be I naught by 2 only because unpolarized light is coming. I naught by I naught coming through. Okay, so cos square theta. I naught by 2 cos square theta. Right. And yes, path axis and be having same path axis. So the difference theta. So here also theta. So here it will be I naught by I2 cos square theta, cos square theta. That is cos square by 4. Sorry, cos raised to 4 theta. Cos raised to 4 theta. This is equal to I naught by 3. Right. We have to find out what is theta. So theta will be how much? I naught we can cut. Cos raised to 4 theta is 2 by 3. Or cos theta is 2 by 3 whole raised to 1 by 4. Single slit diffraction. Or we have to just understand it will be ulta of interference. Here minima will happens at lambda d by d, 2 lambda d by d, and 3 lambda d by d. That is actually n lambda d by d. And here maximas will happen at 1.5 lambda d by d. Right. 2.5 lambda d by d. So the general formula will be 2n minus 1 into lambda d by d. Okay. And this is the question. The question it is saying angular width of central maximum of in a single slit diffraction pattern is 60. The width of the slit is 1 micrometer. The slit is illuminated by monochromatic plane waves. If another slit of same width is made near it, Young's differences can be observed on a screen placed at a distance 50 cm from the slits. If the observed fringe width is 1 cm, what is the slit separation distance? Okay, in first case, it's like this. What's happening there? Central maxima, right? Central maxima. So this is central maxima. Okay. This distance y, and this angle is theta, and this is capital distance d. Right. From this we can say that delta x is equal to d sine theta, which should be equal to n lambda, right? Minimas n lambda. So d sine 60 by 2, that is 30, which is equal to first lambda, because first minima, because like right, this is central maxima. So here it will be first minima. Here also it will be first minima. Okay, 1 lambda. From this we will get d is given as 1 micrometer, right? D is given as 1 micrometer. Yeah. So 1 micrometer into sine 31 by 2 is lambda. Okay. Second case, yeah. Fringe width is how much we know? Fringe width is lambda d by d. So it is now equal to lambda d by new separation, right, d dash, which is equal to 1 centimeter. It's given in the question, right? Yeah, fringe width is 1 centimeter. What is the slit separation distance? What is the slit separation distance? So d dash will be lambda d by 1 centimeter. Okay, lambda is how much? 0.5 micrometer. 0.5 into 0.5 micrometer, right? Into capital D is how much? 50 centimeter. That is 50 centimeter divided by 1 centimeter. So centimeter, we can cut 50 into 0.5. 50 into 0.5 micrometer. This will be how much? 25 micrometer. Easy, yeah, 25 micrometer. So option A will be the correct answer. 25 micrometer. Okay, 25 micrometer. Yes. In this question, theta is 1.22 lambda. Yeah. So this will be 1.22 into 500 into 10 raised to minus 9 divided by d is 200 into 10 raised to minus 2. Right. 200 we can cut 10 raised to minus 7. Okay. This will be 5 10 0 1 5 10 5.1, right? So 5.1 by 2. And raised to minus 7. Prox we will get option A. Thank you everyone.